Welcome to this episode of AU Manufacturing Conversations with Brent Balinski, featuring one of the companies we're putting forward as part of our quest to identify Australia's 50 most innovative manufacturers. This is the first time we've ever run this campaign, and we absolutely, positively couldn't have gone ahead without the generous help of Bosch Australia Manufacturing Solutions, SMC Corporation Australia, and lead sponsor MYOB. MYOB is a business management platform that brings together key workflows to fit business needs. MYOB has been part of the fabric of doing business in Australia and New Zealand for more than 30 years and integrates manufacturing, inventory management and accounting to help businesses streamline business processes. Paul, thank you very much for joining us here on AU Manufacturing Conversations. It's a pleasure to have you on the program.
Thanks, Brent. Great to be here.
And so I'm going to start the show by asking you the question we normally ask our guests first up, and that is, how did you get here and what do you make?
Wow, that's a good question. Look, I've been sort of in or around venture capital, innovation, science for all of my career. And a while ago, I was working with the team at Main Sequence, the CSIRO Innovation Fund, and they were approaching investing from a thematic perspective. How do you resolve for feeding 10 billion people? How do you resolve for climate change? And working within their climate change or their carbon area, we were searching for sort of technologies that could move the dial on carbon. And that's when we were focusing on plastics. And, you can't resolve the climate crisis without resolving the plastics crisis. And we wanted to try and design a technology and a process that could actually resolve what we referred to then as the mixed bale. And we went about searching for the technology worldwide and, trying to find a solution to that problem. And we literally ended up across the road at ANU. They'd been working on this sort of solution as a team at the Jackson lab at ANU for some time, and they had a technology that we felt that was far and away the most advanced technology in the world called enzymatic recycling. We formed an entity then with ANU as part of that entity, Main Sequence and Woolworths and myself, and we began the process of commercialising and developing that technology further so that we could bring it to market and provide probably the first true recycling technology. Most of the other technologies out there are downcycling as opposed to full recycling, and we felt that this was an opportunity to actually bring a technology to market that could actually truly recycle plastic. We weren't going to just focus on, PET or a single plastic. Our approach has always been, how do we resolve for that mixed plastic challenge that there are no solutions for at the moment. So that's how we got here today with Samsara.
So that Holy Grail challenge of the mixed bale is a very interesting one, and we might come back to it in a moment. But before we go much further, I think it'd be good for listeners' sake to have you explain a little bit about enzymatic depolymerisation. How long has it been a subject of scientific and then commercial interest, and what were they doing at the Jackson lab that caught your interest?
The concept of enzymatic depolymerisation has only been around for under 10 years, and it evolved out of a finding in Japan where enzymes were discovered in a tip, effectively, and those enzymes were actually eating plastic. Now, it was taking them an awful long time to actually eat that plastic, and it was an interesting discovery that something had evolved that could actually consume plastic, which has only been around for 50 years. A few research groups around the world looked at that paper and thought, well, maybe there is a way to actually modify those enzymes so that they can actually cut the polymer chain and take it back to, or the plastic or the polymer back to its monomers. And there were 3 or 4 groups that had worked on that. And we felt that that technology was actually going to deliver true recycling. So, not downcycling, but true recycling. And what it does, and the way I explain it is the enzyme's like a little Pac-Man. And it goes in and it sees the polymer chain, and then it cuts that polymer chain and devolves the plastic back down to its 2 monomers. They're the base building block plastic. Now, each one of the plastics have a different makeup, a different polymer chain that needs to be snipped by this little Pac-Man enzyme. But once you've achieved that, and it's only snipping the polymer chain and not actually eating it, you've then got building blocks which are equivalent to the virgin monomers that can then be made back into other plastics or other chemicals. And what's unique about it is that because you've gone back to a molecular level, they are fossil fuel equivalent. So you're effectively taking waste that's already been made. We've made more than enough plastic. We've made 10 billion tonnes of plastic since plastic was invented. So you're taking waste and then you're using waste to displace fossil fuels in the supply chain. So quite remarkable technology that they come up with at ANU, and one that actually sustainably produces a superior product at a very economically advantageous price. And that's what's unique about this particular form of advanced recycling. And what was interesting is that this work was being carried out at Jackson Lab by some PhD students who were intent on actually making a difference, intent on making change, intent on actually solving the plastics and the carbon crisis. And we came across it and we approached the Jackson Lab. Most of those PhDs are now working for us in Samsara.
You may have seen me furrowing my brow just then. The audio was a bit of a lag and I was worried we were going to lose you, but you seem to be back now, so let's continue apace. Right. Tell me about the little Pac-Man or Pac-Mans or Pac-Men or however you pluralise the word. What do they work on? What sorts of plastic are you working with so far?
Yeah, so first thing to mention is that all of these enzymes, these little Pac-Man enzymes that we've got, are new to nature. So they don't exist in nature. We've designed them in a computer to do what we want them to do, and each one of them only works on the plastic that has been designed to depolymerise. We've got a works program currently with ANU looking at 13 different plastics that we wish to depolymerise. What we've got today are enzymes that work on 5 plastics. So we're already at a stage where we can resolve about 50% of plastic waste with our enzymes. The most advanced of those is the same, PET, polyester, they're the same thing. We've got nylon enzymes, we're working on polyurethane enzymes, PLA, polycarbonate, and hopefully soon we'll have another range of enzymes that we can roll out. So these enzymes are active. We've demonstrated them at scale. Polyester is the most advanced, and we're continuing to work to ultimately be able to resolve for the majority of plastics that are on the market today.
And so I'd like to know more on the note of this scaling up. You mentioned that it's commercially attractive, and obviously that's just the most basic thing for any technology to make a difference. Could you tell me please about progress you've made since beginning with, I guess, benchtop tests and, growing the batch size and growing the yield and reducing the cycle times and all the other things?
Yeah, we've actually scaled up very quickly, and one of the unique aspects of this technology is that we don't have a lot of heat in the process, we don't have pressure in the process, and it's a continuous process. So you don't have some of those scale challenges where you've got to deal with mass transfer and other issues that might impact your ability to go from bench to lab. We've already built our pilot line in Canberra. It's producing sufficient quantities of materials now for commercial trials, which we're doing with a range of customers. We're in the process of securing a site just outside of Canberra, which will be our commercial and innovation hub, which will be processing 200 kilos an hour of plastic. So we get into the scale there where we've got sufficient quantities to get products on shelf, to do clothing capsule lines, to do a range of other commercialisation proofs to get it to market. The yield on the process is quite phenomenal. We resolve for 100% of the plastic and recover 100% of the monomers. The only waste that comes out of the process is contamination. So if you've got a mix of polyester and there's some, say, 5% HDPE in that mix of polyester and HDPE, we recover 100% of the polyester. There's no yield loss in the process, and the the HDPE remains unresolved, and we extract that through a filtration process, and that becomes a waste. Now, as our enzyme library continues to expand, the obvious next step would be that any waste that you don't resolve, the HDPE, for example, in that example, you would then put through another process to depolymerise that HDPE. So the yield is quite amazing, and that's because of the change in the process now, a change of approach to actually recycling. That has been part of the key piece of the innovation, is that we've flipped the recycling process on its head. By not having enzymes much on solids, but much on liquids, we've actually achieved these outstanding yields. It's also got a quite amazing carbon footprint, which is really important to understand. By having a carbon footprint that's substantially less than virgin plastic production, we're actually contributing to the sustainability programs of companies that are trying to get to net zero. Other advanced recycling technologies out there, be they other enzyme processes or chemical processing, all actually deliver substantially higher than virgin carbon footprints. So we're way down below virgin. We're a fraction of virgin, in all honesty. The LCA is proving that this actually makes a contribution to those companies that are looking to meet their net zero sustainability goals over the next 20 or 30 years and not impeding those goals. So, as I say, you've got this process that's then economical because you're not using heat, you've got a continuous process, you're not doing things like, having to hold vessels at high temperatures for any period of time because it's nearly all done at ambient temperature. You've got this economic process that then can deliver the new polymerised plastic from the waste that we've recovered at market price. At the end of the day, that's what matters. If you can't meet market price, then it's going to be a challenge to actually get your product into the marketplace.
Sure. And you mentioned it uses much less heat than some other methods. Do you need to provide a little bit of heat, presumably because the bugs are happiest operating in a certain temperature range?
Yeah, so look, these enzymes like to operate in that 45 to 55 degree range.
Yep.
But the enzymatic step is very fast. Our enzymes that we've designed take about 10 minutes to do their job, and the end-to-end process is about an hour. So, if I put something in a bottle or a T-shirt in at one end, I have monomers in about 1 hour. Some of the competing technologies out there, they're having to hold liquids at temperatures of 80 degrees for 16 to 20 hours. And of course, both the environmental and the economic cost of doing that are not insubstantial. It's also our pre-processing step, which has delivered a lot of the benefits of speed and low carbon footprint, where the plastic's never actually melted. Most other processes where you recycle plastic, you have to melt it. You have to get it up to a high temperature to do that. We never melt the plastic, which is fundamentally different in our approach to how to recycle. So you've got low pressure, low heat, and you've got enzymes that act incredibly quickly. All of that in a continuous process delivers you a great economic outcome in terms of the cost of conversion of those plastics.
We'd like to take another moment now to acknowledge our sponsors, MYOB, as well as Bosch Australia Manufacturing Solutions and SMC Corporation Australia. There would be no Australia's 50 Most Innovative Manufacturers campaign without them. Be sure to check them each out via the links in the show notes and give them a follow on LinkedIn. Tell me about designing and breeding the microbes. You mentioned that you design them on a computer earlier. How do you get them to multiply and be in sufficient number to chew through all that plastic and convert it to monomers?
We design all of these enzymes in-house. We use machine learning, artificial intelligence technology that we actually have a long-term fee-free license for with some of the inventors, and that design process allows us to rapidly develop new enzymes. When those enzymes are actually designed and are demonstrating that they can achieve the outcome that we want in terms of the depolymerisation of the plastic, we then grow those enzymes in-house. So it's all done through a fermentation process. The great thing about our model is that we don't actually need a lot of enzyme. Our enzyme to plastic load is very low because we've managed to immobilise the enzymes, which allows us to use them for 7 days before we need to refresh those enzymes. So all of this thinking has gone into how do we actually keep the costs down and our efficiency high.
And I wanted to ask about the downturn in venture investment in the last half a year or so. Do you feel fortunate that you wrapped up your Series A last year, just around the time that VC was sort of running out of puff a little?
Yeah, look, it wasn't easy, and in fact, we noted the change in sort of sentiment midway through our capital raise. So yes, we are very fortunate. The issue that we're addressing, however, is so large and so important that we had the confidence of the investors that we were talking to follow through and close off that round. So yes, we're in a very fortunate position. We are well cashed up to allow the continued development of the science and the commercialisation of the technology, and it is getting tougher out there. I mean, the market is not easy to raise capital in, but I've always said that great technology and great businesses will always attract funding regardless of the market cycles.
And one of the reasons we're speaking is because your publicist got in touch a little while ago and said that you'd like to talk about the proposal of a circular plastics hub. Tell me about what such a hub would look like and what investment it would need and the logistics and volumes and which plastics should be focused on and anything else that are relevant.
We think it's really important that all of the levels of industry involved in recycling are working together to drive a solution to this, be it the collectors of the waste, to the processors, the sorters of the waste, to the people who are actually doing the depolymerisation or the recycling of that product. There are benefits to all of industry to be working closely on this massive challenge that we have ahead of us of creating circularity. For us, we can almost have this relationship with some of the mechanical recycling sites out in Australia that already exist, where we can take the waste from them that can't be taken through the mechanical recycling process, and we can support that mechanical recycling process by feeding back in virgin equivalent materials into their process that will deliver them a better outcome in terms of their plastics. And historically, the market here has been very fragmented. There hasn't been a plan around circularity. There hasn't been infrastructure and support that might exist for driving changes in circularity. That's from legislation all the way through to actually creating, zones, for example, that are appropriately set aside within municipalities for dedicated to circularity. These sorts of concepts are ones where we can accelerate this move towards circularity by coming together of all levels of waste management, of recycling, to then leverage off each other to produce an outcome that will enhance both climate and waste control and management in a way that can't be achieved if we're out there all working on our own. And we're out there talking to partners at the moment about how we can work better together, how we can accelerate this innovation, and what it's going to cost. I mean, Australia at the moment has virtually no polymerisation capacity. We've offshored most of it. We're bringing in our product from Asia predominantly. There's enormous sovereign risk, as we saw during COVID, about not having access to polymerisation or plastic. Plastic's critical to an economy like Australia's. I mean, it's in everything that we do. It touches every part of us every day. Even during COVID, we saw medical issues with plastic where we couldn't access it. These sorts of challenges, we need to make sure that we can bring them together into a combined strategy with all levels of business. All of that's going to be very important going forward. And that's why we'd like to see government drive for circularity hubs where we can actually have a strategy that we can all work together on.
Let's turn to innovation, please. It always looks different across every company, of course. How do you understand the term innovation? What does it mean at Samsara? What would you use to describe it personally and or on behalf of the company?
Innovation is very nuanced, and different people have a different perspective on what constitutes innovation. Innovation is just not about technology. It can be processes, it can be cultural, it can be a whole range of different things that lead to innovation. Samsara is the sort of business where we've been lucky to be able to build it from the ground up with almost a blank sheet of paper. And that's allowed us to actually deliver a new process, a new approach to recycling that was never considered before. We opened the door to actually dismantling the way that recycling from an advanced recycling perspective is approached, and rebuilt that process through different innovation that we've managed to test and trial and use quite effectively. So it's not just the enzyme that makes us different. It's an important part of it, but the fact that we've got a continuous process, the fact that we don't need to melt the plastic anymore, and the fact that we've got no heat in the process, all of those innovations are what deliver what we need to take this to market at a great price. And innovation around the team, around our approach are all important as well. So innovation is, I think that's important in terms of how we frame innovation, is that it's not just a technological advancement. It's a whole host of cultural process steps of the people that deliver the innovation outcome that you're looking for.
And how do you, within Samsara, how do you encourage your workers to be innovative and to develop new ideas and bring them into the organisation and promote and progress them?
As I say, it's a very open process, and we allow people to voice their ideas very publicly and in a forum that we hold regularly, where new ideas are put forward. A lot of people say there's no idea is a bad idea, but we take that very seriously, and we take on board the ideas of the entire team. We assess them, we determine whether they're going to be something that delivers a commercial value or outcome, and we always make sure that they're solving a problem. There's no point in innovation for innovation's sake. You've got to actually be solving a problem. And for us, if you think about the way the company was originally formed, that's at the heart of it. We had the science was the bit that came last. We had the problem, we had the people, we knew what the solution was that we were looking for, and then we went out and found the science to pull that in to solve the problem. So it wasn't just science for science's sake or innovation for innovation's sake. It was all about driving towards solving a problem that mattered in a commercial way. So that's been our approach from the very beginning.
And are there any other problems further than what you've mentioned above regarding some of the other polymers to recycle eventually? Is there anything in the long-term sense where you're working towards that you want to share and point out to us?
Yeah, look, I think when we talk about our role within the plastics industry, we always say that we are just one part of the solution. Don't use single-use plastics, redesign them, reuse them, and then we become the recycling leg. And I think redesign is really important in terms of recycling. Don't use plastics that are going to be incredibly difficult to recycle. Redesign them out of the system. But in many cases, for economic reasons, a lot of people continue to use plastics that will be very difficult in the future to recycle. And I think that's an important aspect of what we need to do as an industry. From our perspective, we're continuing to work on as many of these plastics as we possibly can. I think we're inhibited in some ways in Australia through lack of legislation. If you look at the European model with minimum recycled content mandate that exists across most of Europe now, we have aspirational targets, and inevitably those targets are missed. And you would have seen recently that some of the packaging industry targets of 75% were down in the mid-teens in terms of those targets. And I think we need to take firmer action at a legislative level, and that will then drive investment, it'll drive compliance, and it'll drive innovation, because unless we do that, we'll just continue down this path of simply accepting that the use of virgin plastics and fossil fuels in the manufacture of plastics is acceptable, which it's not.
And lastly, we often close with the question, what's the one issue within manufacturing that isn't getting the attention it deserves by the media, by the public, by politicians, etc.? What would you say is your answer to that?
We've spent a lot of time offshoring our manufacturing, and a lot of manufacturing skills have disappeared from Australia. And I believe there needs to be a concerted effort to actually bring those skills back. The last 3 years of COVID have demonstrated anything is that we need need a domestic manufacturing base, and some of the decisions that we've made around, offshoring manufacturing have created supply chain risk, sovereign risk, a whole range of other challenges that we didn't think were important a few years ago. And I think that concerted effort of bringing manufacturing back on shore, and in our particular case, I look at the fact that we manufacture very little plastic within Australia, and we're shipping it all in from Asia or Europe. It demonstrates the need to actually build up industry again, to rebuild the manufacturing sector and the skill sets, and it will provide enormous benefit to our economy. It will provide enormous benefit to jobs, and I think it's something the government really should be focusing on in terms of their plans over the coming years and how they're going to fund, for example, the reconstruction fund that they're working with.
Paul, I appreciate you're a busy guy, so I also appreciate you donating your time to this program, and it was very nice to speak to you. Thanks for being on AU Manufacturing Conversations.
Great. Thanks for your time, Brent. Appreciate it.
You're welcome.